All right, for people who are joining this live stream, we are talking about a fairly simple function, TextNormalize. Okay. So let's take a look at what's going on here. So I don't understand. Explain to me these various forms.
So these are like different rules for.
Yes, I understand that, but why would one use them, and how do they relate to machine learning models or anything else?
So they're standard, right?
Yes.
And some machine model uses them as preprocessing. For example, the BERT multi-language uses them as preprocessing, so we need them to import the BERT multi-language to our system, which would be great because it might help us do things like text cases in many languages. And it might help everyone doing machine learning models with many languages.
Okay. All right. Okay. So what's the default? If we, I mean, what's the difference between these forms? Let's take a look at what are these different? I mean, if I look at these different forms, so I take this thing here, and I simply look. Well, you've got some examples here, but
I mean, this was just no, this was just when we're designing the arguments and so on. So I think.
Okay, but so let's take your example here, and let's see what it does. Oops. What is that? Okay. Okay, so whereas, what am I seeing with NFC, for example? By the way, I really hope we're fixing the... Okay, well, can we describe a little bit what these things actually do? Can you tell me what they actually do?
Tushita, do you have an idea?
So like I can just
do you want me to just look it up?
So in like first they would do, and like technically they say that they would first decompose, that is what NFD is doing, and then NFC will compose back using certain rules which is prescribed.
Okay, so we need to know a little bit more what the actual description of what these things are doing is. So let me just take a look here.
I can send the Wikipedia page. And
no, I want to see the thing from the standard. From
okay. I can send that as well.
I already have it here. Okay. Okay, so we need to understand what this is doing. So this is turning a ring into something with an explicit diacritical mark, right?
In this case.
Well, canonical decomposition.
And then C will compose it back. So that's the difference between NFD
I understand.
and NFC.
But so what's the difference between the character 00C5? I don't understand these.
I think there's different type of diacritics, and it's kind of, I assume it's going to decompose and canonicalize every single thing. And then
right, but the point is that okay, so these are canonical versions of characters that look the same, right? So we've already addressed a bunch of this in Wolfram Alpha, and it will be interesting to understand what okay. 2075. Okay. All right, I understand. So, I mean, this is perfectly sensible, but it's just, Okay, I understand. That's interesting. That's interesting. So the thing that is most directly related to, as you say, is remove diacritics,
which we thought of including as one of the possible form. That's the whole question. Like, should we extend TextNormalize and make it something bigger, or we keep it to this Unicode thing and then we could have a
No,
more
I think we
restricted
should
name?
make it bigger. I think we should be able to normalize it in different ways. I mean, this is character by character. Well, it's more or less,
because it could also be called Unicode Normalize and be, you know, a more low-level function that just does this 5 Unicode standard transformation. Could be one way to go as well if we don't want to have a big function.
well, I think it would be better to call it CharacterNormalize, because that's what it's doing here. Except that it isn't quite, because it's got the. Is it the case that there are versions in which, you know, 41030A is being turned into? Is there a transformation that goes from NFD to NFC, or is it CharacterNormalize, which is a completely different, you know? So CharacterNormalize would be just taking individual. So does it ever make the string shorter?
Yes.
When?
Don't have.
Well,
I mean,
let's take a look at what it does. So
actually,
let's look at.
Give an example. You just gave an example here. Like the turkey is bigger with NFKD.
No, it expanded it with NFKD. There's no evidence that it.
I see.
That it. Okay, so let's take a ring. Okay, and let's say TextNormalize. So if I understand correctly, NFD should turn this into the character followed by its diacritic. Yep. Okay, so now if I say TextNormalize of that NFC, I don't think it's going to do anything. It is, so I'm wrong. Okay. But this is really character level normalization. I mean, that's interesting, that transformation. Okay, so let's do 1E69 is that S thingy. So let's say we say TextNormalize. So the prediction would be that TextNormalize NFD will have 2 diacritics here. And we're right. Okay, and by the way, those are the examples you should give. You know, it's much easier to understand since most people don't know Korean.
Okay.
Right? So, I mean, what you should start off with is, I would say, I think the example they give, which is capital A ring.
Okay. I am writing notes.
Well, here, I'll just put them in. Yeah, I mean, it's not useful. I mean, it's just like we got to explain what's going on. Otherwise, people just don't have a chance. Okay, so this will be TextNormalize or CharacterNormalize, and then this is NFD, and then TextNormalize of that. We might as well retype the string. NFC is that. Now, and let's just see whether that's actually the same as. Yeah, that's the same. I know it's in that range. So we also want to show, I mean, some of these other things that they talk about here, like for example, I'm sure if we do TextNormalize of slash double struck A. Oh, I should have done the capital. Well, anyway, okay, so do that to NFD. Now, if I'm understanding correctly, that will just throw away the double struckness, but it didn't.
So if you do
Okay.
NFKD, that should throw away the double struckness. I think so. NFKD.
Okay. Well, you're wrong.
Oh no. Yeah. So ligatures like LG, like there's examples later.
Well,
So I
let's
don't
find out
think.
what this. Maybe this is in private Unicode space. Hold
Okay.
on. Let's take a look at where this is. And if it is, by the way, you should make sure that's in the possible issues. Is things in private Unicode space aren't going. Yeah, that's in private Unicode space.
Okay.
Okay. So whatever okay. So this, I mean, this is a very special case of Hangul being decomposable, isn't it? If I pick a random Chinese character, it will absolutely not be decomposable.
Yes.
Right? So let's compare with what we say when we say remove diacritics. Transliterate. I think this should be called CharacterNormalize, because that's kind of what it's doing. I mean, text normalization could be something much more elaborate.
Okay.
I'm not certain about this, but I think let's think about this for a second. Okay, so what do you have any comments on the idea of calling this CharacterNormalize?
So if we say character normalize, then we can just have the Unicode forms like tilde NFKC case fold and leave out the diacritic less lowercase and uppercase. Because
I
they
would think
just,
so. Yeah, I would think so, because
yeah.
that just repeats of other things we already have.
Yes.
I mean,
So
this is a more technical function that is
So I'm okay with character normalize if only the first like few.
Yeah, I
Unicode.
understand. Carl on our live stream is asking, what does this do to an emoji? Can we type in? No, we can certainly make a character code that is in. Let's see, if we say, I don't know how well it displays in the front end yet. From character code of, let's see, what would be a let's try that. Oh, that's not that many. 1 million. Okay, sorry. Let's try the 1 million character code. Okay, so that was, but let's do now this text normalize, because that should have a correct form internally, even though it's not displaying yet. Brilliant. An error of unspecified nature occurred. That's bizarre. I've never seen that before. That's kind of wild. Sorry, 2-character code. Wow. Okay, so that needs to be reported, whatever that did. That's just totally weird. That's totally weird.
So it's a display that has a problem.
From character code, yeah.
I have never seen that before. That is the wildest thing. I mean, because those are within Unicode range. I mean, those are within our existing Unicode range. Well, okay, let's find out what it is. I mean, that may be wow, amazing, far out. Yeah, okay. Yeah, I think this is the right thing. Character normalize is the right thing. Let's, by the way, see what happens if we say whether we know what the character name is for that. Okay, mysteries all around. Wow. Well, you need to ask the people in the front end group what is going on with this. This is very odd. And we could look up this Unicode character elsewhere. That's really odd. That's really odd. What is in that part of Unicode space? Let's just try a random thing there. Yeah. Wow. Ben on our live stream is saying the same error has been coming up when you import Twitter text. That's really weird. That's really weird because this was all working. I mean, we could try it in 12.0, but I think it'll be better. But I wonder what that is. 56208. Let's go look in the Unicode Standard. Hopefully, we can just look up in here. Adopt a character? What is that? Oh, for goodness sake. Huh. Interesting. Okay. Okay, they're selling emoji. It had to come. TLDs, emoji, whatever. All right, let's take a look. Why is this not beyond adopt a character, which I don't think I need? I want to just look up a character. Can somebody look this up? Let's see. Come on, there's got to be a code charts. Oh no. Come now, where is it? Oh, help. I want to just, find by Hex Code. Okay, 56896. Oh, somebody on our live stream is faster to this. Quit the kernel, the error box will still show the character. Wow. Okay. Let's try 56208. Okay, it's got to be in hex.
CCCC.
DB90. What is this? What is this? What's going on? So this normalization is leading to something high surrogate area. So this is really weird, whatever is going on here. So how do we get to this? We got to this by doing a TextNormalize NFD of 1 million. Okay. So something is very weird here. I think this is not our bug. I think this is some kind of Unicode weirdness. Okay. Let's see if we go to gosh, this slow typing in the 12.1 that I have here is really annoying. Let's try this. F4240. What is that? UF000 supplementary private use area. Okay. Well, it got totally confused, and I would argue there's probably a bug in the NFD, in their NFD code. Oh wow, the pink box will actually show the emoji character when it's not been evaluated. That's even wilder. That's really wild. So if I start a new version, it should be able to do that. No, it's not reading 562 as hex. It's correct about that. Very weird. Okay, let's come back to yeah, I agree with Carl on our live stream that TextNormalize is much more like a text function, like text sentences and so on. I think this should be CharacterNormalize. So I propose we rename this, and I think that then we should go ahead and redo some of what it does here. So let's go ahead and do the rename. See if a handy renamer.
Maybe we should wait to see how much extra form we want to add.
We're not going to add any extra forms. What other forms we think of adding?
I don't know. I mean, we could go far, with Transliterate, with like.
Why? We've already got Transliterate.
Yeah. I mean, we already have removed the Diacritic, and
we shouldn't put that in here. I don't think we should have that in here. I think this is purely a character normalizer that's doing these very specific character normalizations.
Okay, so we remove the Diacritic less, lowercase, uppercase. I
think so.
Okay, then it could even be CharacterNormalize, or Unicode Normalize, or something like that.
I don't think it should be Unicode Normalize. It's oops, because I think that we're not naming other things. We chose in the early 90s to sort of standardize our character stuff around Unicode. Okay, so but I think text normalize is an interesting thing for the future. Normalizes characters in string according to what do they call these things in here? Normalization forms. Let's see. I think we can say converts the characters in string to the specified normalization form. Okay, so then I think what we should do here is just to say explicitly, right, we should say that it supports a list of strings. Okay, so I think we just do this. If you don't disagree here, I think this becomes, okay, so NFC becomes, what they're calling it is canonical. Actually, we want to start with NFD, canonical decomposition. Separate out okay, then Now, then the other two forms here. What is compatibility decomposition? What does that mean?
If you have ligatures, then it sort of, separates them out.
Do we deal with this correctly? String concatenation with these things?
Yes, those are the forms. Like that's the example.
No, I understand. But when we, I mean, because, for example, languages like Khmer that have all these totally weird diacritics, like 4 different kinds of diacritics, or however many kinds of diacritics. Yeah, I agree with Sander that examples of these forms are super useful. I think we can give them in the examples. But let me just understand the NFKD. Okay, so that is a what is this thing here? Great. So compatibility tries to turn it into something more yeah, I mean, by the way, I think Carl's comment that it seems wrong not to have diacritic removal. I think, though, that removing diacritics, the point of these things is that they're not losing information. These things are all just recirculating around and not that it seems to be a unique thing. Let's take this example. What is this creature? Help. Do I really have to type this 1E9B? But why is there a 0323 there afterwards? So let's see. 1E9B. Oh, I see. 0323. But that didn't compose. Yeah, you see, that's the problem, is that we're not composing some of these things where there are, and that's what happens in like Khmer, for example. Right? See, that we're not doing that correctly, and almost nobody does. Am I making sense? We probably have the wrong set of people here. I mean, do you understand what this is? This is so don't you have in like French and things dead keys on typewriters? Maybe Etienne is too young to have used a typewriter.
Yeah, well, I was very young at the time.
Well, but you know what I mean by dead keys, right? You press a key and it types a diacritic, but the carriage does not. The thing move.
Yeah.
And this is like that, but in Unicode. And that's how a lot of these I mean, I think oh dear, this is a bit of a mess, if I might say so. I mean, what you're basically doing, which is obviously useful for particularly machine learning type stuff, is just purely implementing these forms.
Mm-hmm. And we'll also put them into NAT encoders.
Yeah, I understand. But they're not, will they have their own NAT encoders?
I'm not sure. Should ask Jérôme. I think he thought about that already. It might be into characters, NAT encoder.
Okay, but how are you going to put them in?
It could be options.
Well, but then why do we have this whole function if its main use is going to be in the NAT encoder? I agree that this function is somewhat useful, but it's still, oh boy, this is such a mess between the rendering of these things, which, you know, as I say, almost no programs get it right for these languages with huge numbers of weird head and feet diacritics and so on. I think I'm not even sure web browsers get it right. Okay, well, let's just think about this for a second. I think it's okay to call this CharacterNormalize. I think removing, since that is after all what is being, it's not a kind of concept that you usually think of. And I think remove diacritics is a, yeah, I don't know. I mean, we could imagine adding that to this, but I think it has its own separate function. Okay, so then apparently, yeah, all right. Well, let's just list what they say these things are, and then let's say, I mean, we've got to have examples here of actual things in these notes of actual. Okay, so what we'll want is a table that just goes the character, and then you know, across the top. Yeah, I mean, in our world, in our documentation, we don't need to so much have to write the character code because you can always copy paste it. Okay, so what I'm imagining here is that there's a grid. Oops, let's just make it here. We make a, wherever this is, what is this alignment? What is this? What is this?
Oh, so this was something we'll need at some point, probably, but because it was not sure, we decided to drop it for 12.1. It's a way to keep, to remember which character corresponds to which character in the input and output. So doing the alignment between the input string and output string. And so we're just like brainstorming the possible language to represent this alignment. There's one that is, we use the same as sequence alignment, where you have, you know, a list of possible things. So I think if you go a little bit upper, yeah, like sequence alignment has this, you know, when the string is in common, there's no list, but as soon as there's a different, there's a list. That would be one way, which I think is nice for the user, but not necessarily nice for a program to handle. So then we thought about.
I'm trying to understand the problem here. So the problem here is you want to, for purposes of machine learning, you're going to normalize the string, but you always want to keep track of, you know, if you're going to highlight some part of the string in the original, you want to know where in the string was this.
Like think of text cases. Yeah, think of text cases or find textual answer, which actually points, you know, have pointers to the original text.
Well, so then this function, what you're doing effectively is you're using this function, but you want it to preserve the, you know, you're going character by character, you're doing this operation, but you want the output to not be, I mean, in a sense, if the way this worked was, I mean, if what happened was that the original character string was effectively, let's say, was something like, you know, was this, then you would be happy if, you know, if the final character, since it's a character by character transformation, right? Then anything that happens would be, you know, if this becomes 3 characters, then you're still good. Am I making sense?
In that case, yes.
I think in all cases of this, if based on what this normalization is doing, that's what would always happen.
But you showed an example of if the diacritic and the letter was separated, then it would compose it.
No, I mean yes, that is correct, but you're not going to be in that situation. That is not a natural form of a string.
I see. I see.
Somebody's asking a question about fermions in physics models. Sorry, wrong discussion. Not talking about that here. Happy to talk about it, but not here. Although, okay, you get this for something funny. So I'm trying to figure out what is the, string rewriting, for example, right? The question is, what is the continuum limit of string rewriting? Okay, so you rewrite a string like you have something like, AB goes to BAA in any string. Make sense? So then the question is, like in a cellular automaton or something, sort of the continuum limit is something like a PDE. The question is, what is the continuum limit of a string rewrite, where the string rewrite is like, that's a good example, something like, something like that. Some string, that's a trivial string rewrite where it's just one character turning into two. Okay. The question is, what's the continuum limit of a thing like this? And the real pun here is that, well, anyway, I leave that as an exercise for the reader. If somebody can figure it out, let me know. I have an idea which is more amusing than you can possibly imagine. Okay, let's come back to this. All right, so I think this is non-stupid, because I think what this is doing is it's packaging little pieces of a character sequence, because I think that the case, there is no naturally occurring character with separated diacritic. If that happens, it is a cheapo way to represent a character, like what we are doing with that foot diacritic thing. Those aren't really separated. Am I making sense? So if you end up with a string where those are separated, I mean, in any source string, they better not be separated. If they are separated, you've got to do something. That's because it was an intermediate string somewhere.
Yeah, I guess it makes sense. We should look at all cases, but there's not one case. I mean, we originally we thought that TextNormalize might do more things.
No, I understand that. I'm saying for what you're talking about alignment, the obvious thing to do is to turn a text string into something like this, then run TextNormalize on it or CharacterNormalize on it. See what I'm saying? Then you have alignment. Then you know where everything is aligned.
Yeah, and so we don't need to have any extra argument to TextNormalize.
That's correct. So I mean, just as a convention, you want to know how things line up, do this.
Yeah, that would work for our purpose, I think.
Carl is asking, should this function actually be an option to characters, like character decomposition method? Unfortunately not, because of this fact that they let's see. So Carl is pointing out that you can, in Irish, you can write something which, let's see if we can paste it correctly. Wow. Okay. All right, fine. All right, so let's see what happens. So the prediction is TextNormalize here will, in the NFD mode, we'll do that. Okay, that's good. Yeah, well, so Carl is pointing out that there's some standard transliteration, but that's a different thing from if we take this and we say transliterate that, right, then it turns into that, which is fine and dandy. But one of the things that, okay, so a separate thing you might need is transliteration with mapping of where the thing came from, because none of these text normalize functions are doing this, so far as I can tell, right? Well, let's see, compatibility decomposition. Let's see what that does on this case. Huh? Okay.
NFKD. Yeah. It would do the same, I believe.
Yeah, okay. Okay, I don't understand then. So there's a separate case, which is transliterate, where you've again got this question of alignment. Right? Which one would have to handle. Now, how would that be handled? Because then we'd have to have a version of transliterate. Yeah, with my proposal, we'd have to have a version of transliterate that takes something like this.
Yeah. For our purpose, I mean, for transliterate, we don't like we don't use transliterate, and I don't think we will. So, I mean, at least no, we would use it, but not in like for I guess maybe. I mean, I don't see immediate use of that for machine learning purpose, at least. Yeah. And generally, you want to train directly on the proper character set. Although
okay.
I guess we might, yeah.
Yes, I think so, because you might have a transliterated text. All right, what are we going to do with character normalize? I think we're going to run out of time right here, but I think first of all, you need a table in here of you know, I could write the code, but I think you can do it, of a bunch of examples of the you know, going across the top, NFD, NFC, NFKD, etc. You know, whatever it is, a standard sequence of characters showing what it does. Now, we're going to have to make some notes, and you probably need to talk to the front end team and others about what we're doing with these characters where we are not rendering correctly. Making sense?
Mm-hmm. Yep.
I had a question. Do we have a default?
I don't think so. I don't think we know what it is yet.
Yes. Yeah. Okay.
Systematically checks if for pairs of character which meet certain criteria. Okay, so it's basically aggregating on the back. It's always assuming the diacritics are put trailing a character, that the key character is at the beginning. That's odd in this case here. Oh, I see, that's a concatenation. Makes sense. All right, let's see if we can, so if we just list whoops, form D. We should list it in the order that makes logical sense here. Etc. Okay, and then give a table, and I think this is what we'll be able to do here, and make sure it's referred to on remove diacritics and so on. I think you need to ask me about this again when you've done this, and when you can tell me how it works with NAT Encoder and NAT Decoder. Let's talk briefly about it again. Okay.
All right. Makes sense.
And then in terms of this alignment thing, I do recommend at least showing an example of how you can use character normalize in a case like that, to where you preserve the locations. And Yeah, I'm trying to think. Carl is noticing that we don't support Irish in the vast majority of functions like Transliterate. Really? Transliterate is using the romanization scheme that I think Transliterate has. It's using standard romanization schemes, but I think we put in several different ones, and we do a pretty good job.
That would be great to improve it still. Huh? There's so we used it for our extended language classifier.
Yes.
Something that can recognize 700 languages and also transliterated ones. And it was not, I mean, for at least the language we tried, it was not so great. Like a native speaker wouldn't transliterate like that.
Okay. It's kind of not our fault because we're using a bunch of standard romanization. Let's pick a word like fish, for example, that we can translate into lots of languages. Okay, there we go. Actually, it's not as many languages as I thought, but let's try transliterating this. This should romanize every one of these, and I don't believe it will. Okay, so Burmese, for example, we have not transliterated there. And I believe that we've been progressively adding transliteration schemes for different languages. But notice that in here, right, those are little diacritics. Those characters there, that is one of these dead key diacritic things that has not been composited.
Mm-hmm.
I mean, this is a mess. This
Yeah. Yeah, I think some of the transliteration was very like it was phonetically correct. But for example, Amir was telling me that for Farsi, he wouldn't write it like that, and no one would really write it like that. It's like when he reads it, it's actually phonetically correct. It looks like the
right.
But
it's like one knows for Russian there are many different transliterations.
Yeah.
And people and there have been between governments mandating that this is how it should be transliterated, and other people saying that's the wrong form. I like poor Chebyshev has how many transliterations? I have no idea.
Yeah.
But I mean, what's surprising is cases like this where there simply isn't any transliteration at all. Oh, there's Khmer with its wild stuff.
So the thing you see for Burmese is also what I see for Hindi or Bengali, the two languages, like I know. So it also separates it out in three, which it should not. I did not exactly know what it meant, like what the term was, but yes.
Where's you mean if you look at Hindi on here, for example?
This one's fine, but like in general, like if you have those the thing that you see in Bengali, the thing you see in Burmese, in this example it's not there. For the fish example, it's not there.
Okay.
But I have seen that before. And
yeah, well, right. I mean, look, doesn't Hindi have joined characters and things?
Exactly. Yeah, there are joined characters with extra we don't call it diacritics, but yes. So it splits it in a way it shouldn't. So
yeah, I know. I mean, it's really hard to render all this stuff.
Exactly. Yes.
And the Unicode character sequence. The thing is that in Unicode they have chosen. In some languages, I think Korean does this. The Hangul characters, which are factored in the composition of a character, are combined into single pieces of Unicode space. But in other languages where there are composited, like, look, obviously French got its accented characters as individual characters, but it's not self-evident that that would happen. That is, if there were two, an accent aigu or whatever it's called, that on a typewriter, that was a separate key, I think. And not something where there was a single key with an accented character. And I think many of these languages have that feature that they get their diacritics by having separate characters that are separated out in the Unicode character sequence. And that's a huge mess because that means when you what do you do if you ask for the characters of the string? There's a syntactic form in which you're, just breaking it character by character by the essentially multi-byte byte code. And there's a choice, right? You could use up a bunch of Unicode space by having all combinatorial combinations of character and its accents, or you can break it like this. And I think in a bunch of languages it's broken, and that's really hard to deal with.
Yes, like in the languages, like most of the Indian languages, the Sanskrit ones, it's broken, so it's hard. Yes, it happens that way, and
Just
we don't.
for my general knowledge, is that
Yes.
are all those scripts derived from Sanskrit, or are they independent?
Not all Indian languages are derived from Sanskrit, but the ones in North India are, and some of them follow general rules, like you are saying, like all the, like, what do you call them, like e, those phonetic things, they have to be broken, like you were saying. So and breaking that is confusing for other people who cannot read it. So
Right. Well, I mean, look, it's right to left languages are even another can of worms.
Yes.
And which we have slowly been solving, but boy, is that difficult. And when you have things like mathematical text that reads left to right in the middle of, it's yeah, I think yes. When is a letter not a letter? Okay, so anyway, for our I mean, and that's what basically this character normalized thing is all about, is when is a letter not a letter? And when do you, because I don't even understand, I mean, the fact that you can decompose E acute, for example, into an E with a separate, acute character it's not obvious why you would want to do that, except for things like machine learning. Anyway, okay, look, I think we got a path forward here for character normalize. This was, despite, this is always what happens when one predicts this will be an extremely easy meeting that will take only 5 minutes. Those are the worst of them. Okay. All right. Any further issues here that we want to talk about? I think there's a path forward here, and don't make a table here. Give some examples of very simple things to begin with here, and let's take it from there.
Yep.
Thank you.
Okay. Thanks a lot. Thanks to
Bye-bye.
folks on the live stream too. Okay. See ya. Bye.